Hello everyone, I'm here to share an exciting new project I've taken on. I just purchased a broken welder. This is an AC/DC 250B TIG and stick welder, and while it needs some work, I'm eager to bring it back to life. The owner mentioned that it exploded while he was welding, which is how I was able to get a very good deal on it. Just to be safe, I need a way to limit the current for the machine. Therefore, I will use a light bulb in parallel with the switch in case I need to bypass the current limiter if necessary. In my country, they stopped manufacturing light bulbs above 60 watt, so I connected two 60 watt bulbs in parallel. This machine is made for the Japanese market and run on 100 volt to 200 volt. Therefore, I have connected to a 110 volt output transformer. If I'm lucky, this 200 volt machine can be converted to run on 220 volt electricity. This is machine's first time power up. Turn on the transformer. Turn on the welder. The bulb glow up due to inrush current and get dim. I check all the buttons and they seem to be okay. Now I turn on MMA or stick weld function and check machine output with multimeter. I expect to get 60 volt DC from the output. You see, the machine keeps turning on and off. I don't know if the welder circuit gets short or the light bulb gets hot and low down the input current. But most important thing, I cannot get 60 volt from the output. I should get at least 200 watt bulb to limit the current, but this time I decide to bypass the current limiter with the switch and finger cross. Now I get 60 volt. I open the machine to see if anything had exploded. Wow, the machine looks nice and clean. It has two floors, I guess one for the controller board and one for the power board. I think this is main controller board because it connected to the front control panel. This definitely tank capacitor for the rectifier. There's a board underneath it, but I'm not sure what it's for. You see a copper coil. This is an HF coupling transformer. It is part of the arc starter board used for the TIG welding function. Those electronic components here resemble MOSFETs, but they could actually be MOSFETs, IGBT or diode. This black component is ignition coil. I want you to know that I have no formal training in electronics. I am entirely self-taught. This is my first attempting to fix a welder, and I would like to show you how I got it done. To diagnose a welder, we first need to understand how it works. This is the block diagram of an AC/DC TIG welder that I get from a welding machine manual available on the internet. This is not manual of my welder, but I think all the Chinese welders have a same design. This diagram have two main parts, controller part and power part. We begin from the power switch through soft start to limit the inrush current. This soft start controlled by the main controller board. The electricity will be converted from 220 volt AC sine wave to about 220 by 1.4 equal 300-volt DC using a full bridge rectifier. This DC voltage is then inverted again by a primary inverter. Some machines use full bridge inverter and some use half bridge inverter. The 300-volt DC now becomes 300-volt AC and go to the transformer to step down to 60-volt AC output, which is smooth through the second rectifier and then become 60-volt DC. Now look at the dot line here. From the slide to the left is normal arc welder diagram. You totally can stick weld if you connected 2 points here to your stick welding clamp. Lot of tutorials show how to convert a normal arc welder to TIG welder. Actually, they just add this block to create very high voltage, enough for the electricity to discharge through the air. For welding aluminum, they need an AC TIG welding function. So they add this second inverter block here to convert from 60-volt DC to 60-volt AC, but this time in square wave. Then this square wave goes through HF transformer, and now you can do AC TIG weld. Now you roughly know how an AC-DC TIG welder works. We continue with the main controller part. Look at these two blocks here. This is the pull switch modulation power supply. You can find this block is in SMPS power supply or ATX PC power supply. They use this block to power up the main controller board. The main controller board controls the solenoid valve for the gas and the fan. Look at these 3 blocks here. This is the pulse width modulator control circuit. You can find this block is in UBS, solar inverter, and battery inverter. They use this block to control the H-bridge on the inverter. These 2 blocks here belong to TIG function. To do AC TIG weld, they drive the H-bridge here with pulse from the main controller board with this block. There isn't much information available about the AC-DC TIG welder, particularly regarding the specific model you own. However, by locating the diagram block on your welder, you can find the IC schematic. This will help you understand each component and determine the input and output of each block, which can minimize the problem area. If you're interested in learning how I do this, please like and subscribe for part 2.